Now, let's look at the part 2 of this course where we are using Kirchhoff current law and Kirchhoff voltage law. Now, if you've not watched the part 1 of this video, make sure you go to the part 1 so that you follow what we are doing here. Now, we've learned about the Kirchhoff current law and the Kirchhoff voltage law. Now, in analyzing circuits, you would want to be using the two laws together in analyzing circuits. But first of all, let's look at how current flow within a circuit. Now, most people always get confused, especially how current move within a certain circuit. So let's say this is 2, 3, 4, 5, 6, 10 volts, 18 volts. Now, one thing we all know is that current leave the positive direction and goes around and make sure that it comes back to where it started from. Now, we should understand that it is by convention that we have taken that current should leave the positive terminal. We all know current are electrons, so they actually leave the negative terminal. But by convention, because we like current, we all first assume current was leaving the positive terminal, but later realized that basically they are the electrons moving and they are negative terminal. We still put by convention that current should leave the positive terminal and go and come back. So let's say if you have a circuit like this, a simple circuit like this, what happens is that the current leave the positive terminal, it goes around and come back to the negative terminal. Then we say that we have a closed path like that where current has moved, and that's how current actually moves. But actually current also mainly leave the negative terminal and goes around and come back. So what it means is that no matter how I assume current to be flowing, it still works out. What happens is that if the current actually was leaving the positive terminal, if I use an ammeter to do the measurement and within the circuit, maybe if the current is going this way, then maybe I get a positive answer. If I just swap the ammeter and the current is going this way, maybe I may get negative, right? So one thing is that most of the time you should not worry much about the direction of current within a circuit like this one. Most students will be worrying whether the current is leaving here, and when it gets here it will go here or it will go there. When it gets here, whether it will go down or it will go up. Most of the time, you should not worry when you're analyzing circuit with Kirchhoff current law or Kirchhoff voltage law about the direction of the current, because current actually can move to the left or to the right. So let's say when you take your house, the amount of the current going from one fan to another fan, you may not know whether it's from this one to this or from the other one to the other one, right? So most of the time when you're analyzing circuits with Kirchhoff, you decide the current direction. So when you decide that the current direction is this, when you solve the circuit, maybe you get 2 amp. If another person decides the current direction is like this, the person is going to get negative 2 amp. Now, this 2 amp and this negative 2 amp are the same current. Just the negative is just saying that the direction should have been the other way. That is all. So when I am assigning current within a circuit, I don't worry about the direction, maybe the direction how the current will flow in these two or in these three or in this four and that. So when I'm assigning current direction within a circuit, what I will always do is that I will assign the current directions anyhow I want it. And one thing interesting is that this is the only part of the course where you can decide to do things anyhow. So let's say I want to know the current in these two. I can say the current is going like this, I1. Now you can show your own to be like this and call it I1. It doesn't matter. Now the current in this 4, I'll call it I2. You can decide to show your own the other way and call it I2. It doesn't matter. All of us will come to the same answers if you follow the same steps that I'm following. Now, the next place, let's say here, ideally, I would want to say call the current here as I3. But one thing is that when you are using the Kirchhoff laws to analyze circuit, the more current you are calling, the more loops you will be taking to solve the circuit. So one thing that you mostly do is to always avoid assigning too much current. And how will you avoid doing that? You have to apply the Kirchhoff current law in the process of assigning current within the circuit. So now, We could see from the class on Kirchhoff current law and Kirchhoff voltage law that if I have this node or this junction here, and I have the current here as I1 and here as I2, then I don't need to call here I3 because I just have a junction where I am aware it's three things there, I1 and I2. The third one can easily be found using the Kirchhoff current law. So I'll say that I1 is entering this junction, I2 is leaving, and the one I want to find, let me call it X, is I1 minus I2. So I will not call here I3, but I'll come and put I1 minus I2 here. So now, when I come to this junction, I only know here as I2. So I have the freedom to call another current I3. Let me say that I want to call this current here I3, and I want to show the direction like this. You can decide to show your own this way and call it I3. It doesn't matter. So now I2, so now that I have I2 and I3, I don't need to call the current here I4 because I'll be introducing too much current. So here too, I'll treat it like this, where I know here as I2, here as I3, and let me say my current here, I want to give it a direction like this. You can choose your own direction because you don't know how the current is going to, whether it's going up or down within the circuit. But your answers at the end of the day will tell you whether it's going up or down. So here I can see I2 is entering the junction. I3 is also entering the junction. But what I want to find, X is leaving. So I'll come and put I2 plus I3 here. So have you seen that I've been able to assign current within this circuit, but I introduce only I1, I2, and I3. Now, in using Kirchhoff laws, every time the number of currents that you have assigned within the circuit would determine how many loops you need to take. So now I have I1, I2, I3. It means that in this circuit, I need 3 loops, and I'll be able to solve this question. So now I'm going to take 3 loops within this problem. So now, have you noticed that I'm coming to solve this problem and I have already applied the Kirchhoff current law during the current assignment? Remember the other circuit that I was solving, maybe I call here I1, I2, I3. I was not really applying Kirchhoff current law in the process of assigning current directions, right? But anytime that you are solving a circuit, to reduce the number of loops you have to take, make sure that you apply Kirchhoff current law in the process of assigning current. And after that, you apply the Kirchhoff voltage law and you'll be able to simply analyze the circuit. So now I want to take only 3 loops and I'll be able to solve this question. So first, let me consider this loop and I want to go in the clockwise direction. I'm leaving the positive terminal. So I'll say positive 18 is equal to the here. I'm following the arrow direction. So I'll say 2I1 plus here too, I'm following the arrow direction. So 3I1 minus I2. This is equation 1. And this one, I'm just using it to explain, so I'm not going to expand it. Let me take this loop. Now, another person could have taken the same loop. Let me also take it in another way. Another person could have taken it in the opposite direction, in the anti-clockwise direction. Now, when you take clockwise, don't go and take the same loop anti-clockwise because you'll be repeating the loop. So let's say I'm going in the anti-clockwise direction. You can see that I will go against the positive direction. So I would have said minus 18 is equal to. Now, in going anti-clockwise, you can see that from here, I'm opposing the current. So I'll say minus 3 into bracket I1 minus I2. Then here too, I oppose the current. So I'll say minus 2 I1. Now, the same equation 1. You can see that this equation is just this equation. If you bring all the ones here to this side and bring the 18 to the other side, you get the same equation. So no matter the clockwise direction or anti-clockwise direction that you take, you get the same thing. So just decide the direction you want to take. But most of the time, what I decide is always to leave the positive terminal of the voltage so that I can avoid a lot of negatives. Or maybe when I look within the circuit and I see that the direction I'm picking, I'll get more positive things instead of more negative, then I'll take that direction. But you can decide any direction. Just make sure you are consistent in the process. So now let me take up this because it's the same equation. So now let me take another loop. I can decide to take this loop in the anti-clockwise direction. You can take any of them. In the anti-clockwise, I'm leaving the positive terminal. So I'll say positive 10 is equal to the here will be what? I'm following this arrow direction, so it's going to be 6I3. Then here, I'm following the arrow direction, so plus I2 plus I3, equation 2. I need a third loop. I can decide to take this middle loop and I'll go in the clockwise direction. Can go anti-clockwise. In this loop, there's no voltage, so I'll say 0 is equal to, then here it's going to be 4I2 plus here it's going to be 5I2 plus I3. Then I'll get to here, which I'm going again, so minus 3I1 minus I2. And basically, this is how, and you see, when I solve this equation 1, equation 2, equation 3 simultaneously, then I'll be able to get my answer. Now, one thing is that if you're able to write equation 1, equation 2, equation 3, the rest is mathematics. So if you're able to write these three equations, you understand that you understand the concept of Kirchhoff laws. Most of the time, students make mistake, especially when they are expanding this and expanding this and expanding this to arrange them for the simultaneous equation. That's when most students make mistakes. So one thing you should know is, as soon as you start making mistakes in those directions, you know that you have to check your mathematics most of the time, not because you don't understand the concept of the Kirchhoff current law and the Kirchhoff voltage law. So you have to expand this, and expand this, and solve it simultaneously. So basically, this is how to use that. So now let me take the first example. Let's say that I'm supposed to solve this example, example 1, and I'm supposed to find the current in the 2 ohm, the 8 ohm, and the 4 ohm. Then that's one important thing about the Kirchhoff laws. Kirchhoff is able to help me find the current in all the resistors within a circuit. Other theorems and laws will not be able to find the current in all resistors at the same time. But that's one important advantage of Kirchhoff laws, because you'll be able to know the current in this 2, in this 8, and this 1 at the same time by applying the Kirchhoff current law. So now let me call here, say, I1, right? Let me call here, say, I2. Now I will not call here I3, because I know I1 and I2. I'll use that one to know what is here. And I'm asking you, what do you think is going to be there? I1 is entering, I2 is leaving, and the one you want to find is also leaving. So let's say X. So X is I1 minus I2. So I'm going to put I1 minus I2 here. Now what happens is that I finish assigning the current direction and I determine my own direction. You can take this question and change the direction and you will come back to the same answers. The only thing is sometimes you may get a negative answer and I will get a positive answer. That is all, but they are all the same. So now let me take this first loop. I will say 32, I'm moving in the clockwise direction. 32 is positive. I'm moving in the arrow 2I1. I'm moving in the arrow 8I1 minus I2. Now this time I'm going to expand. 32 will be 2I1. Now this equation shows you understand the concept. Now in the process of simplifying this, make sure you are doing the right thing. Plus here will be 8I1 minus 8I2. So here 32 will be 10I1 minus 8I2, equation 1. Now, when I take the next loop, like, let me go in the anti-clockwise direction, so that I'll say 20, because I'm leaving the positive terminal, is equal to, here I'm against, so minus 4I2. Here I'm following the direction, so plus 8I1 minus I2. So here will be 20 equal to minus 4I2 plus 8I1 minus 8I2. And I'll get 20 equals to 8I1 minus 12I2 as equation 2. As equation 2. Now, just pick your calculator, because here we are not interested in you solving simultaneous equation. Just pick your calculator and solve equation 1. And solve equation 1 against equation 2. And realize that you are going to get I1 to be 4 amp and I2 is going to be 1 amp. When you do this, you have finished solving a circuit using the Kirchhoff laws. Thank you very much. And in the next part 3 of the Kirchhoff laws, we are going to solve more questions on Kirchhoff laws. Thank you.